Alright, let's take a look at an example of an application of calculus in sciences. Okay, so in this question we have a certain electrical current, I in amperes, can be modeled by the function I is equal to 120R, where R is the resistance in ohms. Determine the rate of change of the current with respect to the resistance when the resistance is 18 ohms. Okay, so the current is a function of resistance here. So we're going to call this I of R is equal to 120 over R. Okay, and we want to figure out the rate of change of the current when the resistance is 18 ohms. So let's first find the rate of change of current with respect to resistance. So we're basically finding dI over dR, right? The rate of change of current with respect to a rate of change of resistance. It's the first derivative of this function I of R. And then we basically get, and what you could do if you wanted to, instead of using quotient rule here, you can write this as 120 r to the power negative 1, right? So in this case we can just employ power rule. So if I do the derivative with respect to dr, you get 120 r to the power negative 1. You basically get negative 120 r to the power negative 2. If I write this as just a positive exponent, this is negative 120 over r squared. Okay, so this is the rate of change of current with respect to the rate of change of resistance, right? Now, what you want to figure out is when the resistance is 18 ohms, right? You want to find the rate of change of resistance when, the rate of change of current when the resistance is 18 ohms, right? So to do that, what I'm going to do here is I'm going to plug in R is equal to 18. So dI over dr is equal to negative 120 over 18 squared, and that's going to give us negative 0.370. Okay, so this is basically going to be amperes per ohm. Okay, so this is the rate of change per ohm, in the rate of change of current in amperes per ohm that you'll basically have at 18 ohms.